What is up, guys? You know what is cool? Exoplanets, and NASA has a lot of them recorded. In fact, there are currently 5,745 planets listed in their catalogue. They feature a lot of useful information, such as distance from Earth, the planet size, discovery method, date, and so on. So today we are going to build a report based on this catalog that NASA has in their website. So this is going to be a 4-part series where I go over all the steps from extracting the data from the site to building the visuals to create an interactive report in Power BI. So without further ado, let's get into it. So here we are in Figma. So to start off, we are going to build the sketch which we are going to use as a layout for the report. So here I'm starting by building a square and I name it filters. So this is going to host the report filters. Then I'm creating a new square and duplicating it. The top one I will call it a description. So this will host the planet descriptions. And then the bottom one, planets, so this will host the planet filters, so you can choose the different planets. Then to the right we're going to build another square, and this one is for the planet attributes. So here we can call this one attributes or details. Duplicating it. Making some adjustments for the placement. And naming the top square distance from the star. So this will have the information about the planet's distance from the star and the habitable zone. Then I'm duplicating the square once more and I will call it planet size comparison. So here we can see the planet's size compared to Jupiter and Earth. Next we are going to design the report background. So here I just went to the Copilot. So here I requested it to create a space background with the planet and a main star in the distance plus faraway stars. So this is what it came up with. So this is the image that we are going to use for the report background. So here I'm copying the image and then saving it to our images folder in the Exoplanets directory. Now back in Figma I will place the image as the report background for the background square. And then I will crop the image so that we get only the desired part out of it. So here I'm choosing to take only part of the planet and the main star in the distance. Once the crop is ready, we can extend the image to the report background size until it fits properly. Then we can start to create the final boxes based on the sketch. So here I'm creating the square for the filters. I will round the edges to 10, then recoloring the fill and placing the stroke. For the stroke we can use gradient, and for the gradient we will create a reflection based on the star's location. So here I'm choosing the one side of the gradient as white for the reflection and another side as the same color the box is, so that we can get a nice reflection effect. Then I'm adjusting the reflection for only the top part until we get the desired result. Next I'm duplicating the square, as we can use the same design for the other boxes. So here I'm placing it for the description and planets. Once more adjusting the reflections based on the star's location. Now duplicating it for the details and the star distance. And finally, when the boxes are ready, we can remove the sketch from the background. Here I made a small adjustment to the crop, so I cropped the background again and moved it slightly so that we get only the planet and the star. Now we can add the headers to the boxes. Here I'm using the bold font with white color, as we are using white for the text in the report. Once the titles are ready, we can group all the elements together. Renaming the group as space, and then we can export the report background. Now it's ready for us to use it in the report. So here we are in the NASA's Exoplanet catalogue. I will include the link to the page in the description below. First we can open up the robots.txt element, which will tell us some information on what's allowed and what's not allowed on NASA's website. So here, when we type robots.txt as a header for the URL, we get some information. So here it says user agent is USA search, and then it says scroll delay 1, which means that we would have to create a 1 second delay between all the scraping queries per URL. And in the allow section we have a marking that there is no restrictions, and also user agent, the star and allow, so there is no bot restrictions. So it's always good to follow the information that is provided to us via the robots.txt file in order to not overload the page and so on. So in order to scrape the data that we need, we have to first see how the page looks and where the page elements are located. So for this I will click on any data points that we want to gather. I will right click it and then I will click inspect, and this will open the site DOM element, so we can view the site HTML and we can see where all the elements are located. So now we can open up the notepad and we can start to create the scraper Python script. So to start with, we have to import a couple of models. So first I'm importing requests, and then from BS4 importing the beautiful soap. So this we will be using to gather the elements. Then we have to import the CSV so that we can write it to a CSV file. And then we can import time so that we can schedule the script to have 1 second pause, like the robots.txt file told us. To begin with, I'm defining the base URL variable. So this variable will host the site URL. So we can go and copy the URL and paste it here. And then where it says page and O, we have to change 1, which basically means the first search result page, what we are seeing now. And we can replace the number with the curly brackets that we will be using to define the range later, so that we can paginate and see all the different search result pages. Next we can create the CSV, so we can define the CSV. So with open we can define the CSV name, we can call it planets.csv, we can put the mode as VWE, so right, and the new line as blank, and then the encoding as UTF-8, and then we can define it as file. Now we have to define the writer So now we have to define the column names that will host the data. So we can do writer equals csv.writer, then file. Then below we can do writer.writeRow, and then in the brackets and square brackets we can input the column names. So here image URL that will host the image, then the planet name, then the link to the planet's detail page, then the information below, so light years from Earth, planet mass, stellar magnitude, and the discovery date. Below we can create the range for the pagination of the search result pages, so 4 page number in range. Then we can define the range from 1 until 384, which is the last search result page. Then we can create a response equals requests.get, and then the URL, base URL, dot format, and we can format the above page number variable. So that goes into the curly brackets above in the base URL. Then we can define the page element search, so the soup equals beautiful soup. So here we do response.content. So we call the above URL as a html.parser HTML format. Then we can define next variable called planet underscore content. We can use the soup.findAll command, and we can search for all the elements that contain this class, this div class hds-content-item class. Then we can define a for loop for planet in planet content. We can call planet underscore URL. So this will get the URL from this div class element that will go into the image URL column. We can call planet.find. Then we can select the source element from DOM. It has the src set attribute, so if that is true, then we can, so if it finds the source in the planet element, if it finds the src set in the planet element under the source tag, then we can call an if command, so if planet URL, then we can define variable src set, just planet URL, and then we can create the list out of the src set. Then we can define first URL, src set dot split, split it by the information that we have with a comma from the first character. Then we split it again to separate the many image URLs that we have in the element. Then we can do an else condition, which is first underscore URL equals blank if it doesn't find the content in the planet URL. So next we can inspect the planet title, so we can see where it's located, and we can define a next search for the planet name column. So here we can do planet.find. We can search the A tag, and here if it finds title from below the A tag, define name equals planet name, and then create a list out of the title. Else we can do name equals blank. Next we can just duplicate the query for the planet name, and we can name it planet link because it's almost identical. So here we just have to change the title attribute to href attribute. So if it finds href, then we can call if planet link, then link equals planet link, append the href to the list, and else link equals blank. Next, we can inspect any of the elements below the planet name title to see where they're located. So here we can see that they are all text elements in the HDS content item inner div class. So here we can define planet attribute or ATR equals planet.find. Here I copied the element from the site DOM to make it easier to get the element names. So here I will do a planet.find all, so it loops and searches through all these class elements. So we can do div class equals custom field, so anything under the custom field. Then an if condition, if the planet attribute returns over or is equal to 4, then we can call the light years from Earth. So for the column we can call planet underscore attribute and 0, which gets the first item, so the first get underscore text strip equals true, so the first text element. Then second, the values for the planet mass column, so the planet underscore attribute 1, so it gets the second text element. And then we can duplicate the same for the stellar magnitude and the discovery date columns. So planet attribute 2 and planet attribute 3. So we can loop through all the elements. Else we can do a condition for all the variables. Else we can define all the variables as blank if the script doesn't find them. Next we can call the variables for the CSV file. So we can do writer.writeRow. Then we can call the first URL variable, the name variable, the planet link variable, and then all the below attributes. Separate them with a comma and then square and round brackets. Last, if you remember the robots.txt file, it told us that it's good to wait 1 second between the queries. So here I defined time.sleep 1, so it sleeps 1 second between every script running. It's good to take into account the time that it sleeps in total. So here we have 15 planets times 380 pages, so it doesn't take that long, but if you have a very large dataset, then you have to consider the amount of time it takes. So next we can open the PowerShell and we can actually run this scraper script. So first I'm creating the virtual environment to the file folder where we store all the files. Then I'm activating the virtual environment when the scripts activate, and then we have to install the requests module into the virtual environment. Then we can install the beautiful soap. And then we can run the scraper script, planets.python. So now when we view the result file, we have all the columns with the values extracted from the site. So image URL, the name, link to the planet details, light years from Earth, planet mass, stellar magnitude and discovery date. Now we can save the file and it's ready for us to use in the report. So now when we have the planet's CSV ready, we can start to gather the planet details from within the planet's detail page. So how we can access the page within the script? We can use the planet link that we already gathered in the first planets.python script. We can open the link. So here when we open the link we can see some further details such as the summary of the planet and other attributes that we don't have in the main page. So we want to access this data and create another CSV file with some attributes. So to start with, we can copy the planets.python script we just created, and we have to do some modifications to it. So first we have to import the RE, so the regex, that we will be using to filter some data. Then we have to create another CSV so we can change the CSV in with open as planet details.csv. Then from the CSV columns we can remove the image URL and also the link, and we can just include the name, star type, label and value. So these are the ones that will gather the elements from the site. Now we can remove the conditions for the planet image URL. We will keep the link as we will be using it to navigate to the detail pages. We can also remove the planet attributes variable as we already have the data, and also the time function below. So to start with, below the planet link variable we can create a variable and call it below, where we defined the planet link URL, and this is going to be the planet detail page URL. So here we can copy the link from the planet details page, we can paste it here, and then where you see the headers we have to replace that with the curly brackets so that we can iterate through the different planet pages. Where you see the headers, we have to remove that part and replace it with the curly brackets, and as that's the value that we can find from the site HTML, and we can use it to iterate through the detail pages. Now below the URL we can define the response, and this is the second response, so we can write response underscore equals requests.get, and then we can use the URL from above dot format, and then we can use the link that we already defined above, which has all the different links to the planet pages. Then we can define variable soup underscore equals beautiful soup response.content, and again html.parser is the format. Then we can define star underscore type. This is going to get, so as you can see we have the star information in the planet summary section, but if you go and filter planets, we can for example choose the Kepler-7b, and when you access the detail page you can see that the summary doesn't include the star type. So this is caused because some of the planet details have been manually modified, while most of them are automatically created to include the same static information. So how we can access the star type information? We can go to the site HTML, and from the top where it says doctype HTML we can just copy the HTML tag lang attribute, so this will get us the whole site HTML. Now we can open another notebooks and we can just paste all the HTML here, and then we can search the star type, so we can see that this information is still stored in the site HTML, although it's hidden. So here I'm copying the element which contains the description, so meta name equals description content. So here we can search with soup.find, we can use the meta as tag, then we can call the attributes as attrs equals a name equals description, and then below we can do a if condition, if the star type, then text underscore content equals star type dot get, and then the content attribute, otherwise blank. Then we can create a match variable. We can define it as regex.search, then we can do rb, and then the wv plus to include whole words. Most of the star types include only letter, but there's also unknown star type, so it will gather the whole word. And then we can do dash type star. So now it will find all the dash type stars from the descriptions. Then we can do end b, and we can define as the text content. Then we can select that it will do the search for the text content. There is a match for the star type star. Then we can define a variable star equals match.group 0, so the first match, and else we can say star equals blank. Below we can create another variable, planet attributes, or attrs, and here we can do soup underscore find all. Here I just came to the planet detail page and inspected the attribute to see where it's located in the HTML. Attribute is located in this long div class name, so I will go ahead and copy this element. I will paste it above the site HTML, and I will just copy the class name. Paste it here, and then we can do a for loop, so for attributes in planet attributes, if condition if attributes, then define a label equals attributes.find, and then from the attributes we can see the attribute text string is located below the div class text bold padding bottom, so we can copy this from the element and paste it as the class name. Then we can define value, which is the actual attribute value, and this one we can see it is contained in the span element, so we can just do attributes.find span, and then we can define the else condition, label equals value equals blank, if there is no match. Then below we can do if condition if label and value. If they are found, then we can call the writer.writeRow to write them into our columns, so name, star, the label and value. For the label and for the value we can just call the text string, get text strip equals true. For this query, as you can remember, it's advised that we would use the 1 second sleep between every link query, but in this case, as we have a total of 5,745 planets, it would take hours to complete the script, so I left it out from the script for this purpose. Now we can save the script, so here I'm saving it as planetdetails.python. We can go back to the PowerShell, open it our file directory, activate the virtual environment. Now when we run the script, we can see that it returns an error, which of course is the class attribute, as class is a reserved word in Python, so it needs the underscore after it. So here I just added the underscore, and then when we run the script again, we can see that it generated the planet details.csv with all the required data. So we have the planet name as an ID. Here you can see all the different star types. Also the unknown type star was found by the regex. And then for the label and the value columns that we need to pivot later in Power Query. Now, once we have the data, we can go to Power BI and we can go to Power Query, and then we can import the planet and the planet details CSVs that we just gathered. So first we can import the planets.csv. We can change the file origin from Western European or whatever you have as a default setting to Unicode UTF-8, so that all the numbers and the text will display properly. Then we can hit OK. First we can use the top row as headers. Then we can start to split the data to create a readable columns and remove all the unnecessary titles. So starting from the right, we can go to the discovery date and split that column by delimiter. we can choose the column, and then we can do the same for all the other columns. So split by delimiter and use the column as delimiter. Now we can delete the unnecessary columns with the title text. Then you can either rename the columns manually or go to the advanced editor, and here we can change the names faster. So I will choose all the names that have 2. That remains from the split columns step. I will just choose them with Ctrl Alt. Then I will remove the 2 from the end so that the header is correct. Now I'm splitting the planet mass column. I'm using the space as delimiter so that we can only show the numbers and then the times multiplier on the right, because some of the planets are compared to Earth and some of them to Jupiter. Here I renamed the column as exoplanet mass and the numbers as planet mass. Next, we can see that some of the columns have unknown values. So here, for example, the stellar magnitude has some unknown values. So we can either replace those in Power Query with the replace values, replace with blank, or we can go back to our CSV files. So here I'm in the planet details CSV, and we can choose the value column and then find and select, and then we can replace unknown with blank. Now also open the planet CSV and we can do the same. We can choose all the columns that we gathered. We can find the unknown values and replace with blank. Saving both files, and then we can refresh and we can see that the unknown disappeared and we get a blank value instead. Now once we are ready with the planets table, we can go ahead and we can import the planet details CSV. Here we can choose the same Unicode UTF-8 as the encoding format. We can remove the extra columns, and now we have to pivot the columns. So we have the label and the value. We can create new mQuery table.pivot using the previous step, and then we can do list.distinct to get the separate column values, and then we can input the last step again, and then the label column, which has our column headers, the label as column headers and the value as column values, and then we can list the first value to get only one of each column. Now we can remove the extra columns, and we are left with the data pivoted. The columns look correct, so now we can go and start renaming them. We can go to the CSV file and we can replace the values from the label field. We can replace the colon with blanks. So now we automatically get rid of the columns and we don't have to replace everything in Power Query. Here I split the orbital period as a number column and the multiplier column. So some of the planet's orbit is calculated in days and some in years. As you can see, there's a big difference in some of the values. Now we can do the same for the orbital radius to get the values and the AU distance measurement separated, renaming the discovery date and formatting it as a whole number. Then splitting yet again with space the planet mass, renaming the multiplier as exoplanet mass and the values as planet mass. Here the discovery method is okay. Also the planet type, so only renaming the titles. Then for the planet radius, another split, and then renaming it in a similar fashion, exoplanet radius and planet radius. As you can see, some of the columns already exist in the planet's CSV, Now, once the planet details table is ready and the data is cleaned, we can go ahead and join the planets and the planet details tables together to get one complete dataset, which is easier to work with. So here I go to the planets table and I merge the queries. We can use the planet name as a primary key for the merge and use the left join. We can untick the use original column name as prefix, and then we can also untick the discovery date as we already had that in the planets table. Also we can untick the planet mass and the planet name, and the table is ready. So here we have all the values from the exoplanet catalog in one table, ready for using. So next we can apply the changes. We can go back to the Power BI report, to the table section, and from the tables we can choose the planets and we can copy the whole table. Then we can go back to the planets CSV. We can create a new sheet and we can paste the table here. We can format it as a table with Ctrl T, and now we can go back to the Power Query. Once there, we can refresh the planets table and it will give us an error, so we have to go back up the applied steps, and then we have to change the column amount in the advanced editor. So when there was 7 columns originally in the planets table, now there is 18. So replace it with 18 and now all the columns will load. Then we can remove all the unnecessary steps and transform the type for all the number columns to decimal number and the discovery date as a whole number. Now the columns are ready, so we can go ahead and remove the planets detail table so that we are left with only the planets table. And there you have it. Now we have the planets table ready for use in the report and measures. In the next episode we will be checking out how to get the planet images, how to modify them and build the planet comparison visual. You can find the links below in the description, and if you like this content, please leave a like and subscribe, and see you in the next one.